Okay, in this video, we're going to give a basic analysis of our 12 basic functions. Our first function is our linear function. The parent function is f of x equals x. You can see the graph here. It has odd symmetry, has no boundedness, no asymptotes, no discontinuities, so it's continuous. It's increasing over the whole domain, and it has no maxes or mins. Its domain is from negative infinity to positive infinity. The range is the same.
Okay. We represent this quadratic function with f of x equals x squared. Below you can see the graph, and the domain is a set of all real numbers, and the range is 0 to positive infinity.
The symmetry is even, and it is bounded below. There are no asymptotes or discontinuities.
The function is decreasing till negative infinity and to 0, and then increasing from 0 to infinity. There is an absolute minimum of 0 at x equals 0.
And we represent this cubic function with f of x equals x cubed. The domain and the range is a set of all real numbers, negative infinity to infinity.
The symmetry is odd, and there are no boundedness or asymptotes.
F of x equals x cubed is increasing at negative infinity to infinity, and there is no extrema or discontinuities in the graph.
This is an inverse linear function, which is also the rational function, which is f of x equals 1 over x. The symmetry is odd because it reflects over the origin, and it also is not bounded.
The horizontal asymptote is x equals 0, and the vertical asymptote is y equals 0. This function has an infinite discontinuity at x equals 0.
Since you read a graph from left to right, it is clear to see that the graph is decreasing in both the first and third quadrants. Also, there is obviously no extrema since there is no official highest point. The domain or all the x values range from negative infinity to 0 and 0 to infinity. The range or all y values also range from negative infinity to 0 and 0 to infinity.
We had the square root function. This parent function is f of fx equals square root of x. This is our graph. It starts at 0, 0 and goes through points 1, 1, and 4, 2. The domain starts at 0 and goes to infinity, including 0. The domain also starts at 0 and goes to infinity, including 0.
There is no symmetry. The function is bound below. It also has no discontinuity.
The square root function is increasing, starting at 0 and going to infinity. There is also an absolute minimum of 0 at x equals 0.
Alright, the exponential function, when b, or the equation is f of x equals b to the x, and when b is greater than 1, it represents growth, and when b is between 0 and 1, it represents decay.
Alright, so neither of these graphs show symmetry. Both of these graphs are bounded below, and they share the same asymptote of y equals 0.
There's no discontinuity. This graph that shows the growth increases from negative infinity to infinity, and this graph that shows the decay decreases from negative infinity to infinity.
The domain and range are the same for both graphs. The domain goes from negative infinity to infinity, and the range goes from 0 to infinity.
This is the graph of the function f of x is equal to log base b of x, where b is greater than 1. 2 points on the graph are 1, 0, and b1. There is no symmetry, and it is not bounded.
There is no horizontal asymptote, but there is a vertical asymptote at x equals 0, so the function does not touch the y-axis.
This function has no discontinuities or extrema. This function is increasing from 0 to infinity.
The domain is from 0 to infinity, and the range is negative infinity to infinity.
Okay, for parent function number 8, we have the absolute value function. The equation for said function would be y equals the absolute value of x.
The graph for the function looks like a giant V, and the domain includes all real numbers, but the range goes from 0 to positive infinity.
The absolute value function has an even symmetry, it is bounded below, and it does not have any asymptotes.
There are no discontinuities, and the line decreases from negative infinity to 0, in which it turns and increases to positive infinity, and finally it has an absolute minimum of 0 at x equals 0.
On parent function number 9, the greatest integer function, it has an equation of y equals the greatest integer of x.
The graph for this function looks similar to steps. The domain for this is from negative infinity to infinity, and the range is all integers.
This function has no symmetry. It is not bounded and has no asymptotes.
The greatest integer function has jump discontinuity at each integer. It stays constant and has no extrema.
This is the logistic function! The parent function is 1 over 1 plus e to the negative x. And here's the graph.
The domain is a set of all x's where the range is 0, 1.
The graph is neither even nor odd symmetrically, but is around 0, 1/2. It is also bounded below and above.
The graph is continuous but has no extrema.
The graph is also increasing and has no vertical asymptotes, but it does have horizontal ones at y equals 0 and y equals 1. Yay!
This is the sine function. The domain is negative infinity to infinity, and the range is bracketed negative 1 to 1.
The sine function has odd symmetry and is bounded above and below the x-axis. It has no asymptotes and no discontinuities. The sine function has an absolute maximum of 1, which is pi over 2 plus 2k pi, and an absolute minimum of negative 1, 3 pi over 2 plus 2k pi, and k is an element of the integer.
This is the cosine function. The domain is negative infinity to infinity, and the range is bracketed from negative 1 to 1.
The symmetry is even and is bounded above and below the x-axis. It has no asymptotes and no discontinuities. The cosine function has an absolute maximum of 1 and an absolute minimum of 1. The absolute maximum is x equals pi plus 2 pi k, and the absolute minimum is x equals 2 pi k, and k is the element of the integer.